Hello students, now we start our next topic in bonding, valence bond theory, also in short called VBT, valence bond theory. Now this theory was introduced in first 1927 by scientist Hitler in London and developed further by Pauling and Slater in 1931. So let us first try to understand the basis of this theory. Okay, how this theory will help in understanding the structure of molecules in terms of energy considerations. Why there is need of chemical bond formation? If you think of why the bond formation take place, because in bond formation energy of molecule as a whole decreases. If for the molecule energy decreases in bond formation, it is favored. Whenever energy decrease, a system attains more stability. Compared to separate atoms, molecule have lower energy after bond formation, because in bond formation energy is always released. Bond formation reactions are always exothermic in nature. When atoms can combine, bond formation will take place, energy is always released. Whereas in bond breaking, energy is always required, it is not due. So for bond breaking, when energy required, during bond formation energy will be released. Now how this energy can be explained here? देखिए what happens as per this theory, आप इसको नोट कर लीजिए पॉइंट्स को, पूरा बहुत सिंपल है, लिख लीजिए. Radon, when two atoms are far apart, from each other, there is no interaction forces. When two atoms are far apart from each other, there is no interaction forces between them. Full stop. When they approach close to each other, new forces of interactions start operating. New force of interaction start operating. Which are new force of interactions? देखिए आपका atom 1, atom 2, we have two atoms given to us. Now in atom we have two nuclei. The two nuclei will have on them positive charge. समझ में आ रहा है? Nucleus have plus charge on each other, so the two nuclei will repel. That is repulsive forces. And at the same time, we also are having attractive forces. Attraction force will take place between the nucleus of one atom and the electrons of the other atom. It is given here. We have two kind of force operating. One is repulsion, force of repulsion. This force of repulsion take place between the two nuclei and also electrons of atoms. Okay, electron in the outer shell they repel and nucleus also repel. So this is causing repulsion. The two nuclei repel each other. At the same time, electrons of two atoms they also will have repulsion among them. And now when repulsion take place, system energy try to increase. This force of interaction, this force of repulsion, it tend to increase the energy of system. समझ में आया? Now coming on second point, force of attraction. The force of attraction, force of repulsion try to increase the energy of system. While we take force of attraction, they will take place between the nuclei of one atom and the electrons of the other atom. In them, attraction force will take place. This force of attraction, it try to decrease the energy of system. This force of attraction tend to decrease the energy of the system. Now what happens if we compare net forces? If the net force taken here of attraction or repulsion, if they can decrease energy of system, if this can taken here new forces of interaction, if they can decrease the energy of system, the possibility of chemical bonding exists. Possibility of chemical bonding is existing. If the new forces they increase the energy of system, if the new forces increase the energy of system, there is no possibility of chemical bonding. Then the possibility of chemical bonding doesn't exist. That the point taken here last one is, if the new force of interactions they decrease energy, then the chemical bonding is not possible, or chemical bonding possibility is not existing. And if the energy is increased, bonding is not possible. If energy decreases, bonding is possible. So I hope it's clear. We have to see कि as a whole systems energy should decrease. So if we have repulsion force less, attraction force higher, then this can decrease the energy of system and then they can favor the chemical bond formation. Now let us explain this point to you. Now suppose we take nucleus one atom, nucleus second atom. This is taken electrons in the outer core. Now what happened? Repulsion can take place where the nuclei are repelling. They repel. Electrons will also cause repulsion. Their repulsive forces. At the same time, attraction can take place where the electrons of one atom have attraction by the second atom nucleus. If you take electron here, it is attraction. And electrons here also have attraction. So we can have attraction force are existing between the electrons of one atom and second atom nucleus, whereas repulsion can take place between the electrons of the both atoms at the same time nucleus. They also can repel. To explain this, if I take formation of hydrogen molecule, let us explain this in energy terms. Formation of H2 molecule. In hydrogen molecule, when we consider, we have two atoms of hydrogen. Now they can have attraction forces and repulsion forces. In hydrogen, let us take here, we can take nucleus taken of Na and electron taken is A, electron A of A atom. And second, we can have second atom of hydrogen. It have nucleus Nb and electron taken is Eb. We have two atoms. If I take atom A and atom B, atom A have nucleus, I can write this one here, atom A have nucleus Na and electron Nb. Atom B have nucleus Nb and electron Eb. Now in these two atoms, when they are far apart, when they have very high distance among them, there are no interaction force possible among the atoms. But when they start coming close to each other, because in bond formation what happens? Atoms have overlapping. When they are coming closer, overlapping should take place. So when the atoms are coming closer, they can have attractive and repulsive forces. Now which they will have attraction force? Force of attraction can take place. किस में आपका वो attraction force? It can be taken nucleus of atom A and electrons of atom A. Same atom nucleus will attract its own electron. At the same time, attraction can take place. Nucleus of A, electrons of B. I'm just writing this one here. Nucleus of A, electrons of B, and nucleus of B, electrons of A. So this can be taken attractive forces. Nucleus of each atom are attracting their own electrons, Nb and Eb. Atoms of same nucleus attract their own electrons, and nucleus of one atom attract second atom electron. Nb attract electrons of A or Na attract electrons of B atom. There are attractive forces. Now what can be taken? Repulsive forces. What are force of repulsion? Repulsion force can be taken. We can take here between the nucleus Na and B, they repel. Electron Ea, electron Eb, they also repel. Electrons are repelling of each separate atoms and also nucleus repel of two atoms. This can be explained if I draw diagrammatically here for hydrogen atom electron cloud. If we draw the electrons, this interaction forces in the atom, it is taken one nucleus, second nucleus. It is taken electron, electron A, electron B, nucleus A, nucleus B. Two atoms are there which are nucleus A, electron A, nucleus of atom B, electron of atom B. Now they can have attraction force here to here. This also will have attraction force here to here. This also have attraction force here to here, and we also have attraction force here to here. Atom, nucleus of atom A attract its own electron and also attract the electron of B, and nucleus of atom B attract its own electron and the electron of the atom A. So electrons on electron attraction and also second atom electron attraction is there by the nucleus. These can be taken attractive forces. So we can have these four kind of attraction forces. Now coming on repulsion forces. Now repulsion force can take place. It is nucleus of atom A, nucleus of atom B. They repel electron of A, electrons of B. They also have repel. They also repel each other. This can be taken repulsive forces. So nucleus of two atoms repel each other, and also electrons of two atoms repel each other. This is two repulsions and attraction taken here. Now what happens when they are coming closer? If energy will decrease of system, then the possibility is there of chemical bond formation. If net interactions can cause decrease in the energy of system, then there is possibility of chemical bond formation. And if net interactions increase the energy of system, then chemical bonding possibility is not existing. Using this point here, now let us draw the energy diagram. Let us draw the energy diagram for formation of H2 molecule. Now using valence bond theory, let us try to understand the bonding in H2 molecule. It has been drawn potential energy curve for formation of hydrogen molecule. See how the atoms will form molecule. It has been explained by the overlapping of orbitals. Now we can take two hydrogen atoms. The graph is drawn. Potential energy in kilojoule per mole. It is 0. Upside we have positive energy, and lower side we have negative value of energy. Now what happens? It is taken this side we take on y-axis. You can take here. We are taking potential energy, and we are taking along x-axis. It is taken as internuclear distance between the atom of two nuclei. We will take first in the beginning. These atoms are isolated. We take two hydrogen atoms which are coming closer. Now when they come close, energy start decreasing. We don't write them at 0 point in any case. When they are coming closer, energy start decreasing. So what happens when the electrons when the atom are coming closer? This graph will read this direction here, not this way. इसका मीनिंग क्या है कि यहाँ पे स्टार्टिंग में एटम दिए हुए हैं, डिस्टेंस के बीच में कुछ दिया हुआ है. Now when the atom are coming closer, their energy start decreasing. Potential energy start decreasing as the atom come closer. It is distance of separation in all the case between two atoms. So now when they are coming closer, energy start decreasing. Already explained why energy decrease, because of interaction forces. We explained to you in this case they are having attractive forces and repulsive forces together. Now we take the net result of the attractive and repulsive forces. So energy start decreasing here, and energy become minimum at one point. When the energy become minimum at one point, then we say that there is bond formation between two hydrogen atoms. At this point they are closest possible. They are the two atoms are closest possible between them, and at this point distance taken is how much here? 74 picometer. This distance between the two nuclei, 74 picometer, is called as the bond length. How we define bond length? It is distance between center of two atoms. This is forming covalent bond. Already explained the meaning or definition of covalent bond. So it is taken, and when the atoms slightly try to come closer, then what happens? Energy again start increasing. It is not meeting this axis. Why? Because the nuclei are closer. When they come much closer, repulsion start taking place. So again, when we try to bring atom closer, the two nuclei are coming very close, and then repulsion start taking place. So it is not meeting this y-axis at any point, because nuclei will start repulsion can dominate, and again energy can increase. So at the point of minimum energy, or we can take stability become maximum, there is bond. This is said to be bond formation condition, and you can take energy difference taken from here to here. This is taken minus 435.8 kilojoule per mole. It is the bond enthalpy. देखिए यहाँ पे क्या है कि in bond formation energy will be released this much. While we take in bond breaking, molecule will break to form two hydrogen atom. Then the energy required will be how much? Same. Energy required become there 435.8 kilojoule per mole. That the energy required to break the molecule into respective atom in the gas state, that energy required is called as bond enthalpy. So for hydrogen molecule, you can say it has bond enthalpy 435.8 kilojoule per mole, because in bond formation from atoms to molecule, we will have here molecule H2 existing. So at the point of minimum energy or maximum stability, there is bond formation, or we have two atoms existing together as a molecule. Okay, that is taken the potential energy curve for formation of H2 molecule. Now let us try to understand. Okay, H2 will form, but helium doesn't form the molecule like He2. That could also be explained by similar interactions in the electrons and the nuclei of two atoms of helium. Let us try to understand that first. Now let us try to understand why He2 molecule is not formed. Why He2 molecule is not formed. We can have, suppose, let us try to first understand what are the developments of the attractive and repulsive forces when two atoms approach close to each other. If I take two atoms are approaching, they can develop some new attractive forces and some new repulsive forces. Let us try to see first here new attractive forces. In the given diagram, they have been drawn by red lines. It is helium atom 1 nucleus, helium atom 2 B nucleus. It is two electrons of atom A and 2 electrons of atom B. Now they are having their own interaction. This nucleus attracts these 2 electrons of its own atom. It is new old interactions, and the new interaction can develop between the electrons of atom B and nucleus of atom A, and vice versa. Electrons of atom A and nucleus of atom B, they will have attraction for each other. This can be taken new force of attraction. In this case, we will have how many new force of attraction by solid lines? We can have 4 in number. 1, 2, 3, 4. So we have 4 new forces of attraction which have been given in this diagram. Now let us try to understand the new forces of repulsion in the same case. Now if I try to show them by here red lines, black lines, or let us draw one separate diagram to make it more clear. Now in this case, let us show you here new forces of repulsion which have been given by here red lines again. Now which can be new force of repulsions? Electron will repel, nucleus will also repel of 2 atoms. These 2 electrons will repel. Electrons also repel this side here. Okay. So this can be taken new repulsions. What is number of new repulsions? We just consider here electron of A, electron of B, means electron of atom A, electron of atom B, they will repel. Electron of A will repel by electron of B. This way also. So total we have how many repulsions possible here? 5. कैसे आप काउंट कर लीजिए? 1, 2, 3, 4 and 5. It is common, so I'm not counting again. So we can have 5 new forces of repulsion. We were having just 4 forces. We were having 4 new forces of attraction, while we are having 5 new forces of repulsion, which have been given by solid lines here. So what happened? They have more repulsion forces as compared to attraction forces. So when the two atoms of helium come close to each other, repulsion will dominate as compared to attraction. So what happened? There is increase in the potential energy of atoms when they approach close to each other, and they can follow this kind of graph here. If I draw the like previous case, energy only will increase of two atoms when atoms are approaching close to each other. So in such case what happen? No possibility of bond formation will be there in helium, atoms to form helium and two molecule. समझ में कैसे होता है कि अगर आपके एटम पास में आएंगे तो क्या होगा? They have more force of repulsion as compared to attraction, and we know that the force of repulsion, they increase the energy of system. When energy increase, stability decrease, and when attraction can dominate, then energy can decrease. We have told condition, only those cases bond formation is possible in which by the new interaction overall, if the energy of the system decreases. In this case, when atoms are coming close to each other, the energy of system increases because we are having more repulsive forces as compared to attractive forces. In case when two helium atoms are coming close to each other, that's the basis for this valence bond theory as well. Even overlapping take place. In valence bond theory, we are explaining the same concept. कि overlapping of orbitals can take place, and they can form two kind of bonds. One is called sigma bond formation if overlapping is head on, and second pi bond formation if the overlapping is lateral between the atoms. So let us take the key concepts or features of valence bond theory. Now let us take the key features of this valence bond theory. First point can be taken, आप लोग सारे पॉइंट लिखते रहिए, write down. पहला पॉइंट लिखिए, covalent bond between two atoms is formed by partial overlapping of atomic orbitals. Formed by partial overlapping of atomic orbitals. Then next point लिखिए इसमें, देखिए which kind of orbitals can form the bonds. इसमें condition क्या है? To have partial overlapping of orbitals, that the orbitals should have electrons. तो right next point लिख लीजिए, each overlapping orbital should have one electron with opposite spin. Each overlapping orbital should have one electron each with opposite spin. Or we can have one more case, if one orbital should have one overlapping orbital should have a lone pair, a pair of electrons, and other atom should have vacant orbital. There are two conditions. If one atom each should have two electrons, the electron should have spin direction opposite. Electrons are having spin direction opposite, they can overlap. And then one more case, if one atom have a pair of electron and other atom has vacant orbital, so one orbital have pair of electron, other vacant orbital, they also can overlap, and the bond formation can take place. Now when we take this kind of electron sharing is called as covalent bonding. This kind of electron sharing is called covalent bond. Now covalent bonds which are formed here by overlapping of atomic orbitals are of two types. They are of two types. क्या क्या type होते हैं? One is called sigma bond and other is called as pi bond. So one is called sigma bond, other is called as pi bond. So let us continue. First we can take sigma bond formation. This sigma bond form, sigma bond is formed by axial overlapping, or can take simple terms, head on overlapping, head on overlapping of orbitals. When overlapping is there of orbitals is head on, axial overlapping, then they give rise to sigma bond formation. Now in this case we can have different categories of sigma bond formation, like we can have S sigma bond. It is formed like in example taken H2 molecule, I can add Li2 molecule. When the overlapping is occurring of two orbitals, each is having electrons in s orbitals. They contain electrons in s orbitals. It is called S sigma bond. Now we can have then SP sigma bond. It can take place like in HF molecule, water molecule. They can have this SP sigma bond formation. It is S, it is p orbital. When overlapping is there, it is called SP sigma bond. Or we can have third PP sigma bond. When overlapping there are PP orbitals. This is overlapping extent here. Or you can add without electrons, you can add directly here. It is overlapping of orbitals. S orbital overlapping form S sigma bond. SP overlapping from SP sigma bond. It is overlapping extent. It is overlapping of PP orbitals. They will form PP sigma bond. So when overlapping is there of orbitals to form sigma bonds, we can find three category common type taken: S sigma bond, SP sigma bond, and PP sigma bond. Overlapping of orbitals taken SS or P and S or P or P, they can give rise to this common category of sigma bond formation. PP sigma bond will form in halogens F2, Cl2. They can show commonly this PP sigma bond. Now next can be taken here pi bond formation. Simple in pi bond formation. Now pi bond is formed by lateral overlapping. Lateral, or you can take here sideways overlapping of orbitals. They can commonly involve p or d orbitals in formation of pi bonds. So we can have pi bond taken here formed by overlapping taken. It is taken one p orbital, second p orbital. When overlapping is taken of two p orbitals, it is nucleus. This overlapping can be explained. It is overlapping extent, or this can be written, it is PP or P pi bond. You can write sometimes by simplification only. See, out of 3 p orbitals, only one can form sigma bond and 2 remaining will form pi bonds. It depends now, okay, which is taken the molecular axis. In common or in general, z axis is taken as molecular axis, or also called as internuclear axis. So Pz forms sigma bond and rest 2, and Px or Py they can form pi bonds. If it is taken when overlapping is lateral of 2 p orbitals, they can form pi bonds. It is common way of writing, or we can just draw for simplification a lateral overlapping of p orbitals which is forming pi bonds is given this one here. Okay. Now we can have pi bond formation by also overlapping of p and d orbitals. Now when we take pi bond formation further, we can have p orbitals and d orbitals. When they can overlap laterally sidewise, they can form the pi bond called as p pi d pi pi bonds. P pi d pi pi bond formed there. Or we can take d orbitals can overlap. When d orbitals are overlapping laterally, they will form d pi bond, or it can be taken, we can show this way, overlapping shown here or interaction in the given 2 lobes. Now when you take d orbitals, you take d orbitals, they have double shape having 4 lobes. So in this 4 lobes, when the overlapping of 2 lobes will take place, they will form d pi pi bond, means they form pi bond. And if overlapping of all 4 lobes can take place, they can form delta bond. Delta bond you don't get question in examination, but I'll explain to you slightly. Means if I take overlapping of 4 lobes, when overlapping of 4 lobes will take place, see the lobes to be selected are the one which are parallel. When this is taken pi bond form, when this is taken lateral overlapping or d orbitals interacting with 4 lobes, such a bond is called as delta bond. When overlapping of d orbital take place involving 2 lobes, they form d pi pi bond. And if overlapping can occur of all 4 orbitals, then this can form, you can take this is taken 1 and this is second orbitals. So such kind of overlapping of all 4 lobes of d orbitals, when they are interacting or overlapping, they will form delta bond. So I hope it is clear, delta bond formation. Now out of sigma and pi bond, which bond you think are stronger? Next one can continue now. Since overlapping extent is more in sigma bonds, so that is the meaning here, sigma bonds are stronger. Sigma bonds are stronger than pi bonds. Simple logic that the overlapping extent is higher. When the overlapping is more, they will form sigma bonds as compared to pi bond formation, pi bond overlapping extent is less. If I suppose show you here overlapping of p orbitals, when overlapping taken here is more, in sigma bond it is pz. If I write here pz, because we take z axis as the molecular axis, so pz forming sigma bond, and then if it is taken pi bond formation, overlapping in lateral overlapping is more or less, it is taken px or py. I can write here px pi bond formation. In this pi bonding the overlapping extent is less, so less overlapping is atom can come less closer or they form weaker bonds. Here they can say strong bond formation, so they are stronger compared to pi bonds. Remember, sigma bonds are always formed first and then only they can form pi bonds later on. So it is taken next point here, sigma bonds are stronger than pi bonds. Now next point you can take here, in which cases the overlapping of orbitals is not allowed. Let us see next point. See, what was the sequence? I think it is G now. No overlapping can occur in some cases. Now one can be taken here, the orbitals which are having wave function not in same phase, they will not form overlapping effectively. When you take here the wave or means when you take here wave functions of atomic orbitals not in same phase, cannot overlap, can't overlap. If I take here like two p orbitals which are having same sign of the wave function coming together, they will form pi bonds. They will form pi bonds. Pi bond formation take place. They form pi bond. If I take the two wave functions which have sign opposite, they are coming together. When they will come together, then what happens? No overlapping take place. If it is taken similarly, if it is taken pz orbitals, if I take this is px or py, if I take pz orbitals, the orbital having the lobes of opposite sign coming together, no sigma bond formation possible. But if the same sign of the wave functions are coming together, then overlapping will take place. They will form sigma bond formation. So in these cases, when the two lobes having sign opposite of the wave functions, here the sign negative or positive does not mean the charge. They are just like in wave crest and trough, for which sign given positive or negative for the wave functions. For the waves, when they are in same phase coming together, overlapping said to be constructive type, overlapping destructive here. So in this case, they cannot form pi bond. Or when they have again the lobes which are having sign opposite coming together, they cannot form sigma bond. But if they coming same sign together, they will form sigma bond. That is one case taken here. Now again we take depending on axis. Second case can be taken, the p orbitals having lobes on different axes cannot overlap. Like if I take here say px orbital, py orbital, no overlapping, no pi bond form. Or can take here s orbitals do not form pi bonds. If you think of a case, it is s orbital overlapping with px or py orbital. No pi bond formation. So for overlapping of orbitals, they should have proper symmetry and they should also have similar energy. There are two conditions. The orbitals to overlap, they should have proper symmetry and they should also have similar energies to allow overlapping effectively in the orbitals. Now if you take the strength of the sigma and pi bonding, see the strength of sigma bond will depend on the extent overlapping of extent. The strength of sigma bonds is depending directly on the extent of overlapping. If the overlapping extent is more, they form stronger sigma bonds. This one to remember. PP will form stronger sigma bond, then SP and then SS. You get in exam question commonly the strength of sigma bonding. होता क्या है कि when you take s orbitals, they are more s orbitals, they have spherical shape, so attraction is more for the electrons of s orbital by the nucleus, so overlapping extent become less. Whereas in p orbitals, due to dumbbell shape, attraction is less by the nucleus for the electrons, so overlapping extent is higher in pp overlapping. In similar conditions, so pp will form stronger sigma bonds than s and p, and they are weak sigma bonds. So this point you remember, you get direct question in examination on this point. अगला point क्या है? Strength of pi bonding. It is again depending on the it also depend on the distance between the overlapping orbitals. We can take here this strength of pi bonding is inversely proportional to distance between the overlapping orbitals. इसको आप लिख लीजिए point को, write down both the points. देखिए strength of pi bonding is inversely proportional to the distance between the overlapping orbitals. Now when we take distance taken here, 2p 2p will form stronger pi bonds, then 3p 2p, or we can take here 3p 3p also. 3p pi bonds are less common because they are more distance among them. While we can take here in the three kind of pi bond taken here, 2p 2p pi bond formation, it have distance x, it is 3d 2p, distance y, 3p 2p have distance taken z. So we can take here x distance is lower, then y and z is maximum. That the reason that 3p 2p will not form pi bond easily. We can show in back bonding concepts, whereas we can have commonly observed p pi d pi back bonding, but we don't have 2p 3p back bonding easily. So overlapping of extent will be depending on the distance. If you have two orbitals more closer, they have in them less distance, they will form stronger pi bond, and then distance more, they form weaker pi bond. Again we can take, when we compare 2p pi bond strength is more than 3p pi bonds. But the common reason we don't find common 3p overlapping of the p orbitals, but we have 2p overlapping very common. If we take the element of second period, carbon, oxygen, nitrogen, they readily form pi bonds. But we take corresponding element of group number third period, like in this below carbon we have silicon, Below nitrogen we have phosphorus, and below O we have sulfur. They are not so willing to form the pi bond. The reason is strength of pi bonding is higher when the overlapping is 2p orbitals than the 3p orbitals. So anyway, it is the basic idea of the valence bond theory. About this strength of bonding base, I will explain one question to you, one concept to you. Bonding in fluorine molecule by valence bond theory. If it is taken bonding in fluorine molecule, we can have two possibilities. If I take, when you take one fluorine atom, what is configuration? 2s2 2p5 is fluorine configuration. I will add two cases of fluorine atoms. Actually, they can show two kind of bonds. If they will form directly one using p orbital, it can be taken suppose x s orbital, then they are p x p by p orbitals. So out of one, only one is unpaired. This can be taken z axis of one atom, second atom pz orbitals. When they will form sigma bonds, it is formation of pz sigma bond. It is pp sigma bond. In second case, if you just think of a case that after excitation they can make available one electron in s orbital unpaired, p can have fully filled orbitals. This electron can overlap to form sigma bond in fluorine molecule. So this can be taken overlapping of s orbitals. Their s orbital having one electron each, when overlapping take place, they will have s sigma bond. We can have two possibilities of formation of a sigma bond between two fluorine atoms. We can have either s overlapping. When s overlapping will take place, they can form s sigma bonds. It will happen after electron excitation from 2s orbital. One of the electron goes to 2p orbital. After electron excitation, they will make one electron available unpaired in the s orbital, and then two atoms, two orbitals are overlapping. Electron have spin opposite to form s sigma bond. Whereas if we have directly electron available in pz orbital, as a common way, we are taking z axis as the internuclear axis or molecular axis. So z orbitals overlapping will form the sigma bond. So it is taken pz from sigma bond. Now in the two which is preferred, first one is preferred. Why it is not preferred? Reason, they are weaker bond. Overlapping extent is more in pp sigma bond as compared to s sigma bond. That the reason के F2 molecule will show or will form pp sigma bond. Are you getting this point? That is F2 molecule overlapping of orbitals. Let us take some more examples of molecules overlapping as per valence bond theory. Then we start hybridization concept. We will see the requirement of hybridization through the more examples taken in valence bond theory. Now if you take formation of some molecules, I am just taking two molecules here. Let us first we can take in water molecule. We have oxygen atom, central atom. We have two electron pairs, means it is electronic configuration of the oxygen atom. We have 2s2 2p4. 2p4 means p subshell have one p orbital have two electrons, rest each is having one electron each. If I am drawing here, it is drawn s orbital, it is p, we have three p orbitals, 1, 2, 3. If one of them is taken z axis, which forms sigma bonds, so other will form sigma bond only here. Because we have hydrogen atoms, we have two hydrogen atoms, they can overlap with the two remaining orbitals. and we know that we have 3 p orbitals are mutually perpendicular. This one here, we can take 3 p orbitals are mutually perpendicular. So of the 3, one have suppose lone pair, these 2 are having unpaired electrons. So what they form? One sigma bond here, one sigma bond here. So what happens? This angle is how much? 90 degree. So if this will be true, then bond angle taken HOH bond angle should be how much? 90 degree. But what is observed? Bond angle in angle HOH कितना होता है एक्चुअल में? 104 डिग्री या 0.5 डिग्री. This observed bond angle cannot be explained by this kind of concept. Again, we can take a methane molecule. First, we can take carbon atom in the ground state. It has configuration 2s2 2p2. After excitation, one of the electron goes to vacant p orbital to make 4 orbitals containing 4 electrons available for bond formation of sigma bond formation. Now, if the overlapping now take place, so we have 3 p orbitals mutually perpendicular. So they will form 3 CH sigma bonds. They form 3 CH sigma bonds, and they have one s orbital with 1 electron will form SS sigma bond, which is uncertain because of spherical shape. We can have infinite possibilities of overlapping of hydrogen's s orbital with carbon s orbital, and then this anyway when possibilities overlapping is there, they will have force HCH bond angles how much? 90 degree. But what is actual bond angle in methane molecule? The actual bond angles all are same, equal to how much? 109 degree 28 minutes. It is observed bond angle or actual bond angle in methane molecule. So these bond angles are not explained by this valence bond theory. This could be explained using concept of hybridization. Now before we take hybridization, we can take a brief differences between the sigma and pi bonds. Then we start hybridization concept. Actually get in exam questions that finding the number of sigma bonds and pi bonds in a molecule, calculation of number of sigma bonds and pi bonds in a molecule. Okay, so that point we discuss now.